Hello, everyone. You are welcome to today's lesson. And this lesson is going to be lesson one of statistics. Okay, we are going to restrict ourselves to core math statistics. But today's meeting will be basically about, okay, the formulas, how to find the various measures, okay, be it measures of central tendencies, be it what measures of dispersion or variability. Okay, in our subsequent meetings, we'll look at, okay, the graph works when it comes to statistics. Okay, so quickly, as usual, I'm going to skip. I won't teach my usual way because, okay, we want to cover. So I will only hit on what you need to know. However, if I'm moving at the expense of your understanding, don't hesitate to let me know. So I'm going to skip the objectives, okay, for this lesson. And the definition for statistics is there. When you read, you understand. So let me quickly move on to the terms, okay, that usually you will come across whenever you are, okay, reading any statistics words book. Okay, and for some of them, they are technical. So where, okay, I need to explain further, I will explain further. Okay, so first of all, whenever we are dealing with statistics, okay, we'll be mentioning data. Okay, as our Nigerian friends will say data. Okay, so here you should know data basically will be a recorded result of what observation. So anytime you go to a field or wherever you look out for information, any information that you are going to look out for, okay, that information when it is recorded, okay, becomes what a data that you can work with. Okay, however, data will come in, okay, three main forms. Okay, it will come in the raw form. Raw form is anytime maybe you want to get the age of students in a class, you enter the class, the first person, maybe you are moving row wise. The first person mentions, okay, the age, you write it. The second, you write. You keep on writing it. So it means with this data, it is not in its organized form, it's the data in its raw form. That's why, okay, we call that data raw data because it will come in its raw form. You have not done any pedicure or manicure to it. Okay, it is in its raw state. Okay, however, the other two, which will be the array, okay, and the group data, that one you have to do some sort of organization on what? On your data. Okay, however, if you organize your data in either ascending or descending powers, okay, did I say descending powers in ascending or descending what order of magnitude? Okay, then you are looking at your data to be an array. An array. Okay, so array, we are dealing with what? An organization of some sort. But you still be writing the numbers. Only that, let's say if you had ages, okay, let me use the example. So with the raw form, these were the ages that you recorded. The first age may be 15, second 17 recorded. But when you are dealing with the array, okay, you list the ages in either ascending or descending powers, like I said. Hey, did I say powers? Magnitude. I don't know why. Maybe because I'm teaching polynomials, okay, in the Form 2 class. Okay, so that's why. So in ascending or descending order of magnitude in terms of size. So that's what you have here. And the group data, okay, and usually this is the data that we use, especially when you are dealing with a big data. Okay, though it has its own flaws. Okay, it is the convenient way of dealing with what a data, especially if your data size is what huge. Okay, and we said when a raw data is organized, okay, into sections or in section units or interval with corresponding sectional or class frequencies, then you are dealing with what a group data. Okay, so in this case, you have more or less a class or a section. So in this case, I'm looking at maybe 15 to 17, okay, 18 to what, 20, and I will come and count. So 15 to 17, I have 1, 2, 3, 4, 5. So it's the same data that I'm organizing, okay, from the raw form to the array and now to the grouped, okay, data. Okay, so that will give me, I count 5. Then 18 to 20, okay, this section, I'm going to have 1, 2, 3. So the frequency will be what, 3. As simple as that. Is my point well made so far?
Yes, please.
Okay, however, you can see there your array, okay, can also be represented in, okay, the, what do you call it, in a table form. However, if you represent your array in a table form, okay, then we'll be talking about what? An ungrouped frequency distribution table. But if your data comes in the grouped form, then the frequency distribution table that you have there will be a grouped frequency distribution table. So this table that you have here is that of the grouped, and this table is for that of what? The ungrouped. So indirectly, I've given you a hint as to the type of what frequency distribution table that usually you come across, the ungrouped one and the grouped one. Okay, and we call it a frequency distribution table because that table, whether grouped or ungrouped, it will always come with a frequency. So you can see that the group here in terms of the section, there is a frequency attached. Okay, this one ungrouped, there is a frequency attached. So that's why it is called a frequency distribution table. Okay, so I guess my point is well made. So another term that you need to be familiar with and will be using often will be classes or class interval. Indirectly, I've mentioned or I have given you a clue in terms of what the classes. Okay, the classes basically will be the sectional units. So this is a class, 15 to 17 will be a class. Or I can say that class interval 15 to 17. So these two can be used interchangeably, either classes or class intervals. Okay, or a class and a class interval. Okay, we use them interchangeably. So I guess so in that case, this will be for me to be, for you to easily relate with anything that I say in terms of classes. Okay, if I'm referring to this class, 15 to 17, I can call this the first class. 18 to 20, I can call it the second class, the next class, third, and what have you, so that you can easily relate. So instead of mentioning, okay, the numbers involved in the classes, I can just use first class, second class, okay, third class in terms of their position to represent what the class as well. Okay, so that is what you have for. Let's move on to the next, okay, term. Okay, so the next term will be the class limits. Okay, so every class basically will have two numbers. Every class, so you can see that we said it will be a section, and the section should have a starting point and a terminal point, or a starting value and a terminal value. So if I have maybe a class 15 towards 17, okay, because we have two numbers involved, okay, we are going to have two limits. Okay, the extreme values are called limits. But usually because we want to distinguish between the limits, okay, the smaller value of the limit or the first value is what we call the lower limit. Okay, and the second value or the bigger value will be the upper limit. So in this case, 15 becomes the lower limit and 17 becomes what? The upper limit of that class. So every class is supposed to have limits, basically. Is my point well made?
Yes, please.
Okay, so I'll be using these terms often going forward. So make sure you get it so that whenever I make use of them, you can appreciate. Okay, so at that point, maybe should I mention, okay, the order doesn't really matter. So let's talk about the class mark or the class midpoint. Okay, anytime we talk of midpoint, even I think today we mentioned midpoint in the relative math vectors. Okay, anytime we talk of midpoint, you should know that there is going to be a common denominator, a particular denominator, and the denominator will be 2. So it's like we are going to divide a certain quantity into 2 equal halves. Okay, so this is it. Whenever you are looking at the class midpoint, so it means with this one, it's peculiar to classes. You cannot deal with what the midpoint if you are talking about the ungrouped frequency distribution table. If what you are dealing with is not in classes, it's not in section, you cannot talk about what the class midpoint, because remember there is a class there, there should be a section. Okay, not just, so that would be, usually we'll say that is what the average of what the upper limit and the lower limits of every class. Okay, so in this case, my lower class limit plus the upper class limits divided by 2, and that would be the average. So in this case, if I'm looking for the class midpoint, okay, of this class 15 to 17, it will be 15 plus 17 over 2. Okay, and you write what? The value, usually the class midpoint is denoted by X. Okay, will represent or will be represented by X. Take note of that. You cannot use this. Okay, I mean pointing, write midpoint this way. So take note. Unfortunately, because of time, I couldn't do all the typing for everything. Okay, I'd even wanted to send you this to read so that when we come, we'll, okay, just fly. Okay, so is the definition for the class midpoint okay?
Yes, please.
Okay, I'm going to introduce the class boundary. Okay, and we'll see whether when you get the boundaries, if you use the boundaries to get the midpoint, we'll end up getting the same value. Remember the formula here for the midpoint uses the limits. Okay, when you learn the boundary, you know that there is a difference between the limit and what and the boundaries. Okay, so let's talk about what's the class boundary. Okay, whenever you are dealing with what the sections, let me go back to where we have the classes, which basically will be the same as the section. If you look at this class, okay, I think let me see the other one if I can still write there. Okay, so assuming I have this class, let's all assuming I'm dealing with the classes, these classes. Okay, what is happening to my, oh, it seems okay, all right. So assuming I have, okay, maybe, let me use the normal one that we have here. Okay, the class 15 to, okay, 19. Okay, then I have another class. Okay, so let me say 20 to 24. Okay, then 25 to 29. Okay, so how many classes do I have there? How many classes? Okay, I want to see if you are alive. How many classes do I have here?
Yes. 3.
How many? 3. Okay, all right. Now, if you look at the classes, okay, this one starts from 15 and ends at what? 19. So this will be in terms of limit, 20 to 24 limit. And assuming maybe you are asked to draw the histogram, and you know that in drawing histogram, you are not supposed to leave spaces between your steps. Or should I say your bars? Okay, you are not supposed to leave spaces between your bars. In that case, if I'm going to, assuming maybe I'm using the limit to draw my histogram. So it means my first limit, the value here will be 15. Okay, then I'm going to get 19. So if I rate the bars will be this way. Then the next one, I come to 20. 20 obviously cannot be here, so there will be a space before 20 will come. Then 20 to maybe 24. By then I have scaled. I'm using this one just to draw a particular point. And you can see that immediately I do this. Okay, what I have here, this is not a boundary, these two. Okay, I cannot talk of boundary. It's what I have is in terms of limits. And indeed, it's in terms of limits because I can see differences between the diagonals. So the diagonal here, 19, this is what, 20, 24, 25. So immediately your terminal value of your first class is not the same as the initial value of your next class. Then it means what you have there is not in terms of what's the boundaries, but rather in terms of what's the limits. Okay, anytime we mention boundaries, you know, when we say that, okay, even with the Ghana map, when we say that, or Africa map, anytime we said a boundary, then we are talking about a common, more or less line shared by two countries or two regions. Okay, there should be a common line. However, if you look at this, there is no common line. So the purpose of the boundary, okay, is to make sure you bridge the gap. Okay, so that when you are drawing histogram, where one line ends, that's where the other one will begin. And now, how then do we bridge the gap? Okay, and this is exactly what you are supposed to do in order to move from the limits, okay, to the boundaries. These are the steps. I'm going to mention them. They are not here. Please take note. I will just mention them. Indirectly, you can see it here, but that is not exactly, okay, so the first step, okay, assuming you can see that there is a gap here between 19 and 20, so I have to bridge the gap, okay, between 19 and 20, move from the limit to the boundary. And what you are supposed to do is find the difference between these two values. So the difference between these two values, what do we have? Is it not 1? 20 minus 19.
Yeah.
1. Okay, this quantity that you have there, divide it into 2 because you want to be fair. Okay, you want to be fair in the sense that, okay, you move this one a little bit to the side and this one will also move, okay, to meet, okay, halfway. So you divide this one by 2. So it's your difference. I'm talking about your difference. So it means you are going to get 0.5. Is that not it? Which is half. Is my point well made?
Yeah.
Okay, so 0.5. This 0.5, this is all that you are going to do. Okay, usually in questions so far, all the questions that we have seen and all the questions that, okay, you see in WASSCE, you always realize that the diagonal differences will be the same. So I am going to treat it as such, assuming that the diagonal differences are the same. And here, indeed, they are the same. This is 1, this is also 1. Is that clear? But I will teach you how we deal with the situation when they are not the same. Okay, right after this. So in this situation, if you have this, that's all that you need to do. You know your 0.5. So you subtract, take note, you subtract your 0.5 from all the lower limits of all the classes. So the lower limit of each class, you subtract was 0.5 from it. And the upper limit you add was 0.5. So lower limit you subtract, upper limit you add this quantity. So it means if I'm moving from the limits, okay, to the boundaries, then this is what, if I take my first class here, which is in terms of limits, I am going to get it in terms of the boundaries to be 15. Is it a lower limit or upper limit? For this
Lower
class,
limit.
it's lower limit.
Limits.
And you say, what do we do to the lower limit? Do we add that quantity or we subtract?
You subtract.
We subtract. So you are going to get 15 minus what? Minus 0.5, which will give us what? 14.5. I was going to mention the answer straight away. Then 19 is an upper boundary, so we add. So it should be 19, okay, plus 0.5, which will give us 19.5. Then you come to the next class. This is lower. You subtract your 0.5, which gives you 19.5. Okay, this is upper. The 24 you add, so 24.5. Is my point well made?
Yes, please.
Okay, then the last class, okay, the lower you subtract, so that will give us 24.5. And the upper you add, so that will give us 29.5. So you can see that now, if you look at the diagonals, okay, you don't have any difference. Where this one ends, that's where this one begins. So indeed, you bridge the gap and you move from the limits down to the boundaries. Okay, your upper boundary of your previous class becomes the lower boundary of your next class. As simple as that. Is my point well made?
Yes, please.
Okay, very good. Any questions at this point? We will be using the boundaries very often, as well as what? The class midpoints. So you need to know this. So my point is well made so far.
Yes, please.
Okay, great. Okay, so I think that explains what you have here as well. Okay, now let's come to the class width. But remember, I told you something that we will equally use the boundaries to do the calculation for the class midpoint and see whether we end up getting the same results. Okay, here the definition is in terms of what? The limit. So let's see whether we can say that the class midpoint or the class mark will be the same as the upper class boundary plus what? The lower class boundary divided by 2, or lower class boundary plus the upper class boundary divided by 2. So let's look at this in terms of the boundaries. So let's go back to the classes. I think we had 15 to 17. Okay, in any case, okay, 15 to 17. Okay, and the other one was what? Okay, I think it was 18 to 20, right? I guess, okay, it was 18 to 20. I stand to be corrected though. I can still make my point. So if I'm talking about this, the diagonal, I have only one diagonal here. So the difference is what? 1. So I will divide by 2 and subtract from all the lower and add to all the uppers. So we are going to get what? 14.5, okay, to 17.5. I hope you are with me.
Yes, please.
Okay, then, so 17.5 to 20.5. but I'm interested in finding the class midpoint of this class. Okay, the first class, because that's what we did here. We use the first class, however, we use the limit. So find the sum of these two and divide by 2, and let's see what you will get. You get the same thing, right? Okay, so 14.5 plus 17.5 all over 2. And that will give you, so you still get 32 on 2, which will be what, 16. I hope I'm right.
Yes, please.
Okay, so you can see that what the limits can do, okay, the boundaries can do as well. Very soon you will know something. Okay, so in this case, we can equally calculate the midpoint using what? The boundaries. Take notes. All right, now let's come to the class size or the class width. Okay, and anytime we talk about width or size, obviously, you know, we are going to look at the difference. Okay, the difference. So here we are going to look at the difference between two quantities. And if you look at the class size, you can see that we say is the difference between the upper class boundary and the lower class boundary. So the definition is in terms of what? The boundaries, not the limits. Okay, we will try and calculate using the boundaries. Then you go back and use the limit and see whether what the boundary can do, the limit also can do. Then after that, I will give you a very simple advice. Okay, so now let's see if I want to calculate the class size of this particular class. And you can see that what I have here is in terms of what the boundaries. What is here is in terms of the boundaries. Okay, so in terms of the boundaries, if I'm looking at the class size, which obviously we said, the definition is in terms of the boundaries. I'm going to have my upper class boundary, which is 17.5, minus my lower class boundary. Okay, so please, okay, give me the difference. What did you get?
3.
You had 3. Okay, that's exactly what is here as well. Now, assuming we want to use the limits. Okay, so let's use the limit and see whether we get the same results as 3. If you want to use the limits, then it means here you can see that this one, it was 15 to 17 in terms of the limits. I hope you are with me.
Yes, please.
So 15 to 17. Now let's use the limits and see. So if the class size is defined in terms of limits, then it's going to be the upper class limit minus the lower class limit. So you are going to get 17 minus 15. Is that, would that give you 3?
No, please.
No. Okay, so you can see that what the boundary can do in terms of certain calculations, the limit cannot do. However, what the limit, okay, can do, the boundaries can do as well because of the definition here. So my advice is anytime you are asked to calculate either the class midpoint or the class size, okay, use the boundaries. You get my point?
No, please.
Okay, I said you realize that, okay, though the midpoint is defined in terms of the limits, but when we calculated the midpoint using the boundaries, we ended up getting the same result. Is that not it?
Yes, please.
So it means what the limit can do, the boundaries can do as well. Is my point well made?
Yes. Yes.
Okay, now you come to this. This one, the class size is defined in terms of what? The boundaries. Okay, but we said though it's defined in terms of the boundaries, let's go and use the limit and see if you get the same results. Okay, but we use the limit and realize that we didn't get the same results. So it means what the boundaries can do, the limit cannot do. However, what the limit can do, the boundaries can do as well. You get the point?
Yes.
So in order for you not to be confused, okay, class boundaries, or sorry, class size, we use the boundaries. Okay, the class midpoint, we use the limits. In order not to get confused, I said all the calculations, you know, boundaries all the way. So all of them, you calculate it in terms of boundaries, period. And you'll be safe. You get the point now?
Yes, please.
So it means indirectly you define your class mark or class midpoint in terms of the boundaries. So yours will be the lower class boundary plus the upper class boundary over 2. As simple as that. Afa?
Yes, please.
Okay, good. All right, so now I think I can move on to the next. Okay, so we are going to look at the various measures. Okay, and here we are going to talk more, and I'll be calling you one after the other. Okay, so please, okay, make sure you are very attentive. Okay, so we'll be looking at our first set of measures, which will be the measures of central tendency. Okay, and the measures of central tendency is simply a measure of the center of the distribution, central. Okay, so anytime you calculate the mode, the median, the mean, okay, the mean, we have geometric mean and we have the arithmetic mean. Usually when you talk of mean, without it being qualified, then we are talking about the arithmetic mean. But we also have the geometric mean and the harmonic what mean, okay, which at your level, we don't teach, especially the harmonic mean. But the geometric mean, I think series and sequence, we have geometric mean there. Okay, so I will concentrate on the mode, the median, and the mean being the arithmetic mean. I won't talk of the geometric mean and the harmonic mean here. So these are the very, okay, most important, what do you call it, measures of central tendency that you need to be very familiar with. However, you know the 3 will be mode, median, and mean will be, okay, what you need to know. And they are all measures of what? Averages. Okay, usually you think it is the mean, that is what? The measure of what? An average. Okay, take note, it's not only that. Mode measures average as well as what? Median. So take notes. Okay, however, you know, okay, when we talk of what the here is supposed to be, there should be mode here. So we are going to take our first measure, which is what? Mode. Okay, and obviously this will be the most occurring observation. The most occurring observation, or the observation with the highest frequency, you know, JHS. Okay, now take notes. Okay, every I should say statistics question, which will be on the measures, be it measures of central tendencies or the measures of what? Dispersion. The question may come in 3 forms. It's either the question will come in the raw data form. So you'll be asked to find, okay, these measures given a raw data. Or the question will come in, okay, where you are given an ungrouped frequency distribution table. So the question will come in the frequency distribution table form. But the frequency distribution table, remember I told you we have 2. We have the ungrouped frequency distribution table and that of the group. So these 3, you have to be very, very okay in terms of doing the calculations on them. Raw data, okay, on grouped frequency distribution table and grouped frequency distribution table. So each measure, okay, will move from the raw to the ungrouped and to the grouped. Okay, but my point is, anytime you know how to quote the formula for the raw, okay, you know the formula for the grouped or ungrouped frequency distribution table. So indirectly, you know the formula for frequency distribution tables, be it grouped or ungrouped. So please listen and listen attentively. There is a particular trick that it can help for you to move from the raw data formula towards that of what? The grouped or ungrouped frequency distribution table. So now let's look at the mode from the raw data. And I know, so assuming you are asked to find the mode of the following numbers. Okay, so let's see. The first one, what do you think is the mode? Anyone to help? You know the observation with the highest frequency. So let's see. 1 is appearing once. 2 is appearing how many times? Once. 3 is appearing 3 times. 4 once, 5 once. So what observation has the highest frequency or appears the most?
3.
3. So in this case, if we are looking at the solution, okay, so this is it from the raw data. So solution, okay, A, your mode, okay, will be equal to 3. Okay, and here usually your measures are supposed to have units. If you don't know the units, just leave it. However, if you want you to attach the units, we'll tell you, okay, the units, will indicate the units, okay, in the question, so that when you do your calculation, you attach that as well. Okay, so B, okay, what do you think will be the mode? Study the data carefully. I hope you can see clearly.
Yes, please.
Okay, so what observations? What is the mode? I'm waiting. Okay, let me see. Seems somebody has sent. Okay, all right. Do you agree that the mode will be 3 and 4?
Yes, please.
Okay, so here, okay, we have 3 and 4. Okay, the frequency of 3 is what? It's 3, and that of 4 is also what? 3. So they have the same. Okay, so that's what we have there. Let me come and continue with the C here. So assuming, okay, my C. Okay, so now let's see. C, what is the mode? Anyone with the answer? What do you think will be the mode?
2, 3, and 4.
2, 3, 4. Okay, 2, 3, 4. Do you all agree?
Yes, please.
You all agree? No objections?
No, please.
Okay, all right. Okay, I object. Okay, take note. You all fell victim. Okay, before you can get the mode, you should get at least one observation with few occurrence or with a lower, okay, number of what occurrence, frequency. Okay, assuming your age, okay, I mean, all of you have the age of 20, I'm just assuming. And I ask you, who is the oldest? What answer will you give? Will you be able to tell who is the oldest?
No, please.
You will not. Before you can mention the oldest, there should be someone, okay, who will have a less age. I hope you get my point. So anytime you have a data of this sort, okay, and you can see 2 is appearing twice, 3 is appearing twice, 4 is also appearing twice. Okay, all the observations, they have the same number of frequencies. So in a occurrence, so in this case, okay, when you have that situation, there is no mode. And don't go and write 0. Mode is equal to 0. Be careful. The meaning is different. I hope you agree. Should I come again or my point is well made? It's my point well made. Some of these questions you have to watch out, especially objectives. Okay, so that you don't fall. That's the more reason why I already moved straight away. So the questions are carefully selected. So what we have here, okay, this is unimodal data. So uni 1. Unimodal, because we had only one observation. This is bimodal. Okay, so take notes. It's not always that your mode will be 1. Okay, I mean, one observation can be more than 1. Okay, and you can equally not have mode as well. Okay, so in view of that, what will be the mode of what? The D. What will be the answer? What will be the mode?
No mode.
Okay, no mode. Okay, now I'm doing something to see. Okay, tell me what the mode will be. So I've added 1. What will be the mode? Immediately you get it, then at least I will know that you got exactly what I said. What will be
4 and
what will be the mode? It will be 2, 4, and 3 now,
4.
because now you have at least one observation, okay, having a less, okay, frequency, number of occurrence, which is 1. So it means the rest will be your mode. So here we are going to have a trimodal data. Is my point well made? All correct. Okay,
Yes,
so now
please.
we know how to find the mode from, okay, a raw data. Let's go and look at finding the mode from an ungrouped frequency distribution table. Okay, so again, that one is very easy. Just go to the frequency, okay, the observation with the highest frequency, will be your, your mode. So in this case, if you look at this question, the solution will be from this data, or table. Our mode, will be equal to here, which age?
3.
3. So you just write 3. Is that okay? I want to know whether you are paying attention to detail. Remember, I told you, ordinarily, your measures are supposed to have units. Here, because we're dealing with numbers, so we didn't attach the units. But here, we are dealing with age. So don't forget, and you are told that age here is calculated in years. So your modal age, in this case, or your mode will be 3 years. So once the question uses the short form, you can, use the short form. However, if this is written out in the full form, then make sure you also write it in the full form. Is my point well made?
Yes, please.
Okay, so mode from what do you call raw data, and that's of what the ungrouped frequency distribution table. Okay, you have it. And if you look at the frequency distribution table here, you can see that is a frequency distribution table for this one. Okay, usually, so let me quickly teach you how to move from the raw to the, what do you call it, ungrouped frequency distribution table, which more or less can be in terms of the array. Okay, so this is it. Okay, so the observation, any observation that you have there, when you are writing it, you write it once. Okay, if it will appear more than once, it will be taken care of by the frequency, in this case, row, not column. Okay, so 1 is appearing once here, so the frequency will be 1. Okay, by then you maybe draw or indicate a row or column for your tally. Then you move on. But here, I don't need a tally. It came. So 2 is appearing how many times? 1. Okay, 3 is appearing how many times? 3 times. Okay, 4 is appearing how many times? 1. Okay, and 5 is appearing what? Once. So it's the same data that you have. Only that here you were dealing with numbers. I added what? Years to this for you to know that if it comes with units, when you draw your conclusion to, your conclusion must also be. So remember, they should be therefore here. Take notes, therefore, okay, then therefore here as well. Okay, take notes. So this is it. And when you are looking at it in terms of the ungrouped frequency distribution table, when you are listing your observation, okay, you list in, ascending powers. Usually because you will construct your table in the column form. Okay, so your age in years will be here, and you start with the least age, followed by the next age 2, 3. So you can see that it will be, increasing downwards. So it will be ascending, downwards. It's my point well made. So that's how you move from the raw to the, ungrouped frequency distribution table. Now, this is where I am going to talk just a little, and we are going to work just a little. All right, so let's look at this. Finding the mode from a group frequency distribution table. Unfortunately, that is not that easy. But thank God we are all smart, we are professors. This formula that we have here, don't worry, you will find it in the formula book, which will be provided to you, in WASI. And please, it will be provided to you on request as a student. It will be available in the exams hall anyway, but until you request for it, you cannot, or you won't get it. So please take notes. And usually the advice is, because the book not enough, I'll tell my students, so immediately you enter and you say start work, you just request for it. But I realize that if every teacher gives this advice, there will be chaos. So you only request it when you need it, but don't wait till when you need it, then you request. Maybe going forward, maybe you are maybe 2 minutes or 3 minutes before you realize that you would need it, then you can put up your hand and request for it, so that by the time you are ready to use it, you have it with you, for you not to waste time. I hope I'm clear.
Yes.
Okay, so just ask before you did it. That's mine. So this formula is very easy for you to relate. Okay, and here the L that we have here, I'm defining all the parameters here. Okay, mode is equal to L plus change sub 1, and you know, okay, those of you delta sub 1, the econ student, they will know that in econs we use this to represent change. Okay, small change. Okay, change. So change sub 1 plus change sub 2, okay, times C. The whole of, so I'm going to define all the parameters. So L will be the lower class boundary of what? The modal class. Take notes. So if you don't know how to find the modal class, problem will come. Okay, now let's come to this one. Change sub 1. This is the essence of the modal class, okay, frequency. That's the frequency of the modal class over the next lower class frequency. I will explain. It is not difficult at all. And very soon you agree with me. Okay, I will explain. This is just English. Okay, I will break it down for you too. Immediately time we talk of Essex, you know that we are going to talk of difference. Is that not it? How much this one, okay, has over this one more. So SS. So we'll be dealing with differences in terms of the change. So change sub 2, essence of the frequency of the modal class over the next higher class frequency. Okay, so again, all that we are doing here is with respect towards the modal class. And again, if you can see the class size, which we know, okay, how to find. And I think I didn't add this. The class size, which is the same as the class weight, is usually denoted by C, small c. Take notes. Just as I said, the class midpoint is usually denoted by X. Okay, I think I forgot to mention that of the class size. I was so glued in, okay, teaching you how to do the calculation. Okay, so now you know. Now, what do we do? Class size of the modal. Okay, class. So here we are looking at C will be the modal class size, basically. Okay, and as you quote the formula, if you know, it is not necessary for you to come and write the whole of this. You just need to write their value. So as I move on, in terms of the calculation, you appreciate. Okay, so let's see. Find the mode of the distribution below. And you can see that here, the ages that you have there are in terms of what classes. I know if you are not preview to what I'm going to teach you, if I ask you to find the mode, okay, you just be frank. What would you have said? Okay, assuming you have this data, you know you use the frequency. So using the frequency, what would you have said? I mean, using the data here in terms of the frequency, what would you have said is the mode?
25 to 29.
Very good. I know most of you will say that, if not all of you. And 25 to 29, it is not a value. Okay, so you cannot say that a mode, all the measures must be specific values. But you can see that what you stated, okay, is a class or it's a section. I hope you agree with me. So you
Yes.
rather stated the modal class, not the mode. So the modal class basically will tell you that the mode will be, okay, in that class. So the mode cannot be outside 25 and 29. That's the meaning. So if you are able to get the modal class and you do your calculation and you realize that your calculation lies outside your modal class, then it means there is something wrong. Go back and check. Is my point well made?
Yes, please.
Okay, very good. So in this case, let's see how best to use this formula. Okay, so solution, that's the first thing that you write. If the questions are normal, you normal. Okay, the next thing that you are supposed to do always, whenever you are dealing with a group frequency distribution table, the 2 columns given, you must always extract. You will be adding to the columns as and when you need them. Okay, so in this case, I know, okay, my age, my 2 columns given. But in terms of what I per experience, I know that I'll be dealing with the modal class. I also be dealing with class size. So if I'm going to talk about class size, I know that class size is calculated in terms of the boundaries. You remember? I hope you are with me.
Yes, please.
Okay, and even with this, the
Yes,
first, the
please.
L that we have there, we are told that we need to look for the lower class boundary of the modal class. So it means we will need the boundaries. Okay, as you become smart, okay, and experienced, sometimes you only concentrate on the classes that you need, okay, and go and look for their boundaries. You won't do it for all of them. But usually you need all the boundaries because of follow-up questions. So you have to come and create your column for the boundaries. Okay, so your class boundary, you can see here, the diagonals, the differences are 1. I know I said I will teach you the situation where the difference, okay, not 1. But for now, let's restrict ourselves to that. I've not forgotten. So diagonal differences 1, 1, 1, 1. So it means in this case, okay, you are going to divide the 1 by 2, and you will get 0.5. So you subtract 0.5 from all the lower class limits and add what 0.5 to all the upper class limits. And that gives us all that we have here. So it will be 0.5 minus 0.5, which gives us this. Then you add what 0.5 to the 9. So you subtract. If you like, you can subtract from all of them and come and add. Okay, but usually by experience, immediately you get this, you know the next one. You come and get this, you know the next one, because you know that that will be the pattern. So now I know my boundaries. Okay, but before you even go and add, okay, your columns, my advice is, first of all, quote the formula. The formula that will tell you the columns that you need. So in this case, I'll come and write mode or bat mode, okay? In terms of the formula from the group will be equal to the L plus what? Change sub 1 over change sub 1 plus change sub 2. Okay, that's not all. The whole of that's in bracket, then times C. Okay, so now I'm going to look for my L. Okay, so I'm going to write but my L. We said L is what? The lower class boundary of the modal class. Is that not it? That is the modal class lower boundary. I hope you are with me. So now what is the modal class? You said the modal class is this. Is that clear? Because that's the class with the highest frequency. I hope you are with me.
Yes, please.
Okay. Now, if this is the modal class, we said the L is the lower class boundary of the modal class. Okay, this will be the class boundaries, okay, of the modal class. What is the lower class boundary here? Is it not 24.5?
Yes, please.
Okay, so that is 24.5. Okay, I write it. Comma, my next one is change sub 1. Okay, and this is where you need to listen attentively. I'm going to break the English down. Okay, we said it will be the excess of what? You can see that we are going to deal with excess of frequencies. Okay, and always your classes that you have there, as you move and you go down, you move from a smaller class, okay, to a bigger class. So that's why you see 5 to 9, 10 to 14, 15 to 19. So this class is bigger, not bigger in terms of size, but bigger in terms of the values involved. Is that clear?
Yes, please.
Okay, so I will use lower, okay, and what? Higher class. So in this case, okay, you can see we said excess of frequency of the modal class over the next lower class frequency. So this is the modal class. All the frequencies above the modal class are lower class frequencies. I hope you agree. All the classes here are lower compared to this. You agree, right?
Yes, please.
And all the classes that will come below will also be higher classes. So take only that here we have only one. But we said it will be the excess of what? The modal class frequency over the next. When we talk of the next, it will be the closest lower class. I hope you are with me. So it means we are referring to the difference here between these two frequencies. And that is your change sub 1. And that will be equal to 10 minus 6, which will give us what? 4. Should I come again?
Yes, please.
Okay, all right, okay. Ekuya, is that you? Prof. Ekuya?
No, it's not me.
Okay, it was who?
It was Kezia.
Kezia, okay. All right, okay, so it's just English when you get here. So we are looking at what we said. Let me read again. Excess of what? Frequency. So it means we'll be dealing with frequencies. Is that not it?
Yes, please.
So the difference that we are going to deal with will be in terms of what the frequency. So essence of the modal class frequencies over the next, okay, you can see that because that is the modal class, okay, the modal class frequency, that is the biggest frequency. So always when you compare it with another frequency, there will be an excess. I hope you get my point.
Yes, please.
Okay, so now we are saying that it will be the excess of the frequencies of the modal class over the next lower class. So this is the modal class. This is its frequency. What is the next lower class? 20 to 24. Is that not it?
Yes, please.
Not lower because you have to come down. Lower in terms of the values. I've explained that. So if I'm looking at the excess of the frequencies of the modal class frequency over, okay, the next lower class frequency, then it will be 10 minus. So change sub 1 here will give us what? Okay, the excess of what the modal class frequency. The modal class frequency is 10. Okay, minus what? The next lower class, and that is what? 6. So that indirectly will give us what? 4. Is my point well made now, Kezia? Kezia, are you there?
Yes, please.
Are you fine now?
Yes, please.
Okay, then, okay, we come to change sub 2. And if you look at what the definition here, we said it is the excess of what frequency of the modal class over the next higher class frequency. So this is the lower class, so the modal class, okay, frequency. The next higher class is this, and its frequency is this. So if you find the difference here, is the difference here that will give us the change sub 2. And the change sub 2 here, please, when you are doing you don't do this. You are supposed to come and write it here. I'm just using this to explain. So you cannot come and write here. Okay. So you are going to get what? 7, 10 minus 7, which will give us what? 3. So in this case, it will give us 10 minus 7, which is equal to what? 3. Is my point well made? So what parameter is left in the formula? What parameter are we left to find?
Class size.
The class size, the C. So, and the C, remember we said, okay, small c, is what? The modal class size. So this is your modal class. And we know the class size is not calculated in terms of limits. I've even told you, even what is calculated in terms of the limits, I've advised you not to calculate it, which is what? The class mark or the class midpoint. You still use the boundary. Okay, so in this case, what do we have? We are going to find the class size here. So the difference, I'm looking for the difference. Okay, great. Okay, I'm looking for the difference. What do you think will be the class size? 29.5 minus 24.5. Oh, why are you doing this? Hurry up. Okay, all right. Okay, we know we can do this mentally. That is 5. Okay, so thank you, Kobe. I've told you that some of these calculations, you have to do it, okay, and tell me the value to make the class interactive. Okay, so at this point, I can come and write therefore my mode, okay, will be equal to, okay, L give us what? We said 24.5. Okay, plus, okay, change sub 1, and change sub 1 give us 4. All over change sub 1, which is 4, plus what? Change sub 2, which is 3. But that's not all, the whole of that times C, which is what? 5. So we are going to get, remember, as you move from one line to the next line, you write close to the margin because of the constrained nature of then you create room here. So what do we get? This one is 24.5. So we are going to get 24.5. Okay, then plus, this gives us what? 4 over 7. Okay, the whole of that times 5. So I think you can continue from here. Okay, so that gives us 24.5. Then plus, okay, now this will give you 20, okay, over 7. So use your calculator. And when you use your calculator, what do you get? Okay, I think, okay, Kobe has been very consistent with right value. So I want to see if I can pick his values and work with it. Okay, so I have here 27. Okay, 0.35. Okay, so what I want the actual value. Kobe, was this exact or you approximated? Hello, my professors, are you there?
Yes, please.
Okay. And what did you get? Give me the value and let's go. We have to cover.
27.35.
35. Was it exact?
3571.
714
Very good. Remember, I've told you. Okay, your first approximation must be how many DP?
4 decimal places.
4 decimal places. So here, the question, it requires that you need to approximate. But your first approximation must be 4 DP before you take it towards your convenient approximation. So first approximation, give me the 4 DP.
3571.
1. Then you put in bracket. Okay, don't forget you are dealing with years. Okay, then you put in bracket for DP. Anytime you approximate, don't forget to indicate your approximation. However, this is not all. Okay, usually we say that in age, unless otherwise stated, leave your answer to 1 DP. So you move this one to 27.4 years, and you put in brackets 1 DP. Is that clear? So your first approximation and the convenient words approximation. In years, usually the convenient approximation will be 1 DP. What about currency? When you are dealing with currencies, what should be the ideal approximation? How many DPs?
2.
2. So please, you need to know this. Okay, these are low-hanging mass that you shouldn't lose. Is my point well made? And here, if you forget the years, you are doomed because like I've told you, we are dealing with, we know the units. So you have to attach what? The units. So this becomes what? The modal what? Age from this what? Frequency. All correct? Okay.
Yes, please.
All right, great. Okay, so now, okay, I guess we can move on to, okay, we'll do more questions. So we are going to move on to our next measure, okay, which will be the median. Okay, median. All right, today, at least I have to finish with all the measures of the central tendencies. Okay, so let's finish with the median, then I will give you, okay, so let me see. Okay, let's hold on. Okay, let me give you 3 minutes water break. Okay, by 5-7, you should all be back stretched. Do whatever you have to do to keep yourself very active, rejuvenated for the task ahead. Okay, so let me pause. When we come back, then we resume. Okay, so welcome back from the water break. Okay, now, okay, we are going to look at our next measure of central tendency, which will be the median. And median, basically, you know, anytime you are asked to find the median, you are looking at a particular value midway again. But we know we are dealing with central, okay, tendency. So sometimes because, okay, median, you think it's only the median that will be located inside your data. But I've said that, okay, the mode as well should be inside. Okay, then the mean, you shouldn't go outside. Okay, your extreme values, you should be inside your data values. So for you to find the median, here, the first thing that you have to do is to arrange the observations or the items in either ascending or descending order of magnitude. But usually we go for ascending, not descending. Okay, then after you arrange, you have to look for the median position. Is the median position that will give you the observation that you are looking for to be the median. So it's the median position that will help you count and know your counts. Okay, so in this case, let's look at a situation. Okay, and usually you'll be confronted with 2 situations where if you are dealing with a raw data, okay, where your observation the normal observation will be even, and where your normal observations will be what? Will be odd. If it is even, how do you deal with it? If it is odd, how do you deal with it? However, please take note. I'm going to give you one formula that will work for both odd and what? And even. Okay, take note. So here, let's look at the solution to this particular question. Find the median, okay, from finding the median from a raw data. So you are finding the median of these or sets of numbers. So solution. Okay, A. Okay, I'm going to arrange. So let's arrange the numbers that we have here in, okay, ascending powers. Or let me see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, so here this one is cancelled. So it's 2, 6. So let's arrange. That will give us 2 in ascending, 3. Let's go. 5. 6, 8. Am I right? Hello, my professors, are you following? You are not responding to my liking.
Yes, please.
Okay, very good. All right. So now you've done your first step, which is the arrangement, very critical. Immediately you fail to arrange, you are doomed. Okay, if you get the answer right, then that will be magic or you'll be lucky. Okay, but if it's a subjective question and you don't arrange, oh no. Okay, so in this case, you want to find the median. So you need the median position. So median. Okay, this is the formula. Okay, in terms of the position. So if I quote the formula, you know that I'm dealing with the position. So median position will be, okay, n plus 1 all over what? 2, okay, th, okay, position. So immediately you see th, you know that I'm talking about what? Position, but not the median. I will need the position to find what? The median. Is my point well made? Okay, take note. This particular n plus 1 over 2, you can use it for both core and, so did I say? You can use it for both odd and even. No issues. Okay, I'll tell you, okay, as to what to do in each situation. So here, let's go and count where our n will be the number of observation. So the median position will be 1, 2, 3, 4, 5. So it will be 5 plus 1 over 2. Okay, don't forget your TH for you to know that you are dealing with the position. Okay, so this will give us what? Okay, 6 over 2, which indirectly will give us what? The third position. Please, because there is TH here, you know, okay, don't think that you always write TH. Now, usually it is TH. That's why we use TH in the formula. But if it is second and what have you, now change this one to RD. Is that clear?
Yes, please.
Okay, so it means after your arrangement, the observation occupying the third position will be your mode, sorry, your median. So in this case, I'll know now go and write there for my median. Okay, will be equal to, I go and count. Okay, from the left to right, 1, 2, 3. You can even move from the right to left, you end up getting the same thing. First, second, third. So the observation, okay, occupying that position will be what? 5. So the median is 5. Is my point well made?
Yes, please.
Okay, so here we had odd. Okay, now let's look at a situation where we have even number of what? Observation. So we are going to look at that of the B. Okay, it's not well arranged, but no problem. We can still, okay, squeeze. So B, the observations are, so we are going to giving you rearrange. So let's rearrange. 2, 3, help me rearrange in ascending powers. 5, okay, 7, am I right? Or 6? Okay, 7, then 8. Hope I'm right. Okay, so now, okay, I'm mature, so I'm going to write, therefore, median. Okay, I will quote it in terms of the position anyway. It will be n plus 1 over 2 th. Okay, immediately I remove the th, then it means the answer there is my median. Okay, so now what do I have? N. count the number of observations where n will be your number 1, 2, 3, 4, 5, 6. So we are going to get 6, okay, plus, okay, 1 all over 2, which will give us 7 over 2, and that is what? 3.5. Am I right? Don't forget your TH. TH. Am I right?
Yes, please.
Okay, so this is it. Okay, usually in books, they will tell you that if your observation that we have there, okay, is even, okay, it will be the average of what? A particular number and another number. So they will tell you that it will be your n plus 2, then the next observation. Okay, however, please just use this formula. The 3.5, okay, immediately you get a decimal. It's trying to tell you that, okay, your median must be between 2 positions. And it will be the 3rd position and what? And the next position, which will be the 4th position. So you go and take the observations, okay, occupying these positions, then you find the average. So you add these 2 observations and you divide by 2. Should I come again, or my point is well made?
Please come again.
Okay, so you realize that if you had maybe 3, then that would be exactly a whole number, an integer. That will give you the 3rd position. If you may be 4th, then you can easily go and pick. But here you've been told what we have here. Okay, you found it to be what? 3.5. 3.5 is not an exact position. And I'm saying immediately you use your formula and you get 3.5, and you get a decimal, not an exact value. Okay, I'm talking about a whole number or an integer. It means you are going to find an average of 2 numbers. And how do you find the number? So we said 3.5. So it's 3.5 will be between the 3rd position and the 4th position. Is that not it? I hope you are with me.
Yes, please.
Okay, so I go and look for the 3rd position. So it means this will be equal to, the 3rd position will be, okay, 1st position, 2nd position, 3rd position. So that will give me 5. Plus the 4th position, because it's supposed to be between the 3rd and 4th. That's why it is 3.5. So the 4th position, which is the next one, okay, the number there will be 6 all over what? Over 2. So that gives me 11 over 2, which is what? Okay, 5.5. Am I right? Okay, very good. So you get it. Okay, let me see. Kobe, is that how you were taught? Come again.
Yeah, that's how we were taught.
Okay, with only one formula, not the other one. They will tell you to use them.
I think the one they made mention of was for even numbers, you use the n plus 1 over 2 formula. And for odd numbers, it's just n plus n on 2, yes.
N on 2. Okay, all right. Okay, so anyway, so it can see that you were given 2 different formulas. Is that not it?
Yes, please.
That's my point. But here, I'm using only one formula to do all.
I think both of them work. They work equally. So
yes, they work equally. But the more you learn formulas, the more, okay, you get my point. Okay, that's the more reason why I always want to. You can see that even in calculating the class size and what have you, I said use this particular way. Because the more you learn more formulas, okay, the more the formulas, the more confused maybe you become. Sometimes you get to a point, oh, when do I use it for this situation? When do I use it? But if I know that this one works for all, I don't ask myself that question. Okay, I can use it under all situations and it makes my work easier. Okay, that is me. All right. Okay, so let's move on to, okay, I think we are not done with this. So let's see, okay, how you can find the median here and the median for this one as well, before we come to finding the median from an ungrouped frequency distribution table. So please do the A and the B for me. I'm waiting for your answers. You should all try. I'll call all of you, okay, to give me what you had in terms of the A and B and see whether we had the same result. So I will pause here. Okay, so the A, you are supposed to have 6. Okay, and the B, okay, your median is supposed to be 11.5. Okay, so go through exactly what we did here. One is even, one is odd. and I've told you, you use the same formula. Okay, if it is going to give you the sum of two values divided by 2, the average, then when you find your position will be decimal. Okay, as simple as that. Okay, good. Okay, so at this point, we are going to look at, okay, another, okay, situation. If you look at what you have here, you can see that this time around, we are looking at finding, okay, the median from ungrouped frequency distribution table. This is all that you need to know. You can see that anytime you are dealing with what, a frequency distribution table, be it grouped or ungrouped, okay, you have to be very careful in terms of your formula. Okay, you just have to know the formula for the raw data. If you know it, there is always a trick to move from the raw to the frequency distribution table, okay, formulas. And by that, this is what I mean. Okay, anywhere in any formula from the raw data, you know your individual observation, so you can get your counts, so you can get your N. But from the frequency distribution table, you cannot tell the individual observations directly. Okay, you won't get what your N, you cannot count them. Your N will always be represented by sigma F, the sum of what? Of the frequencies. So it means in finding the position, when you are dealing with what? Grouped or ungrouped frequency distribution table, your position, which is the median position, okay, that's how you find your median position. So that will be equal to, this time right, it will not be N, it will be sigma F, okay, plus 1 all over 2 TH. Okay, wherever you see N in the formula for the raw, it will always be sigma F. Is my point well made?
Yes, please.
Okay, very good. Take notes of this. There will be an extra information that will help you move from the raw, okay, to the frequency distribution tables formula. Okay, so in this case, if I need to find my median position, I have to find the sigma F. So in the solution, you sum your frequencies. Okay, so sigma F will be equal to here 1, 2, 3, 4, 5. So that will give us 5. So I'm going to get this to be equal to 5 plus 1 over what? Over 2. Don't forget
Mr.
TH.
Hartman,
Yes, please.
please, can the median also be written as half sigma F?
Half sigma F.
Yes, please.
Yes, I think someone said that we use that one, okay, under a particular situation, and we can use this one under another situation. But remember, I said use this one for all. Okay,
Yes,
but when
please.
we talk of when you talk of the grouped frequency distribution table, okay, usually anytime your data, your sigma F, okay, is what greater than or equal to 20. Okay, when you are using it, you can divide by 2 without adding that one in the formula. Okay, you will get there. But for now, I'm saying that whether what you have there, okay, is even or odd, okay, add 1 and divide by 2. So we are going to use this formula for all. Is my point well made?
Yes, please.
Okay, so this gives us 6 over 2, which again will give us the third, okay, observation. Now, how do we get the third observation from the table? So you just go and count. Usually, like I said, ungrouped or grouped, okay, your observations will be in, what do you call it? Ascending powers downwards or ascending powers, okay, from left towards right. Take notes. Did I say, okay, let me use powers for magnitude, okay, indirectly. Okay, so now this is what we have. Okay, if I want to count my first observation frequency will be occupied by the number 2. My second observation will be occupied by the number 3. Please, are you following what I'm doing? Hello,
Yes,
are you
please.
following? Okay, your first observation will be occupied by the number 2. If you add this one to this, we are going to get what? Okay, 2. So this means your second observation will be occupied by the number 3. Your third observation, okay, will be occupied by the number 5. But I'm looking for the observation occupying my third position. And the third position, the observation there is what? 5. So it means I'm going to get my median to be equal to 5 for what? Years. So I can write therefore here as well. Is my point well made, or I should come again? It's the same data. It's the data that we have here that I represented in the frequency distribution, okay, table form, but that's of what's the ungrouped. Is my point well made, or I should come again?
Please, your point's well made.
Well made, very good. Okay, so now, okay, we'll do more, don't worry. Okay, so we have another one here. Okay, so let's see, okay, how to find, okay, the median. So we know that median, we are going to use one formula for all. So we won't even ask whether we are dealing with odd or even. So I won't go and sum and check whether I'm dealing with odd or. So I will quote the formula straight away. Because I'm dealing with a frequency distribution table, it becomes sigma f plus 1 all over 2 position. That's the median position. So that will be equal to sigma f. So I go and sum. So my sigma f here, the sum. Okay, so let's sum 6, 10, 13. So I'm going to get 13 plus 1 all over what? Over 2. Don't forget your TH to indicate that that is not your mean. That's the position. So that will give us 14 over 2, which is what? 7th. So 7th position. So now we go and count and see. Okay, and this is how you check the position. Okay, this is 1. The frequency here is 1. So it means the first position will be occupied by the highest 4. Is my point well made? Okay, now if you add this, you are going to get what? 6. So it means from the second up towards the 6th position will be occupied by what? 5. Do you agree?
Yes, please.
I hope you are following. Okay.
Yes.
Then, okay, if you sum this, we had 6. So that would be up to what? Up to the 6th position. The 7th, so if you add this, we are going to get what? This plus this, we are going to get what? 10. So it means from the 7th position up to the 10th position will be occupied by the number 6. All correct. But we are interested in what? The 7th position. So this is where, okay, our position of interest is. And the 7th position up to what? Up to the 10th position, we said will be occupied by 6. So it means the observation occupying the 7th position will be what? 6. So it will be therefore, and remember, this one came with a unit. Okay, so the median height will be 6 meters. Point well made.
Yes, please.
Okay, all right. Okay, so on that note, try the D for me. Then we'll come and look at it together. Okay. To get the same result. Okay, so let's look at, so this is that of the D. So I was giving the solution to that of the C, rather, forgive me. Solution, then C. Okay, questions are numbered because we want you to number your solution. So solution to the D. D, okay, we know median. Okay, will be equal to sigma f because we are dealing with a frequency distribution table. No n, th. Okay, in the statistical, okay, or the formula book, okay, they use capital N to represent sigma f. So please, okay, take notes that if you see n, we are talking of what? Sigma f, the big N. Take notes. All right. Okay, so here, what do we have? If you go and sum, okay, 5, 6, 7, okay, 10. So the sigma f is 10, am I right? Okay, plus 1 all over 2. Don't forget your TH. If you continue, assuming this, oops, my line looks ugly. Okay, assuming this my next page, this will be equal to, okay, 11, okay, over, okay, truth position. Okay, we could have written the value there straight away. And that will give us what? 5.5. Am I right? So it means your observation, you'll be dealing with two observations. The fifth position observation and the sixth position observation. You put the two together and you take the average. Okay, you divide by 2. Okay, so now fifth position, we are going to count. Okay, first up to the second position will be occupied by 7th. Third up to the fourth position will be occupied by the observation 8. Okay, so this is fourth. Fifth position will be occupied by 9. So I know one of my observations of interest, 9. Plus, okay, my other observation, that is the sixth observation, will be occupied by 14. All over what? Over 2. So it means I'm going to get what? 23 all over what? 2, which gives us what? You know, that will give us 11.5. Do we have units? We do. So percent. And you can write your therefore here. So the 11.5% people, okay, have it. Okay. It's my point well made. Kezia, are you fine now?
Yes, please.
Okay, only that in that situation, this should be n, your number of counts, because you can count your observations. They came individually. Okay, so at this point, okay, we are going to look at our shelf, okay, that of the, what do you call it? The grouped frequency distribution table, because that is strictly in elective maths. So when we are doing elective math statistics, I will pick the elective math exclusive, okay, situation, then we'll deal with that one. So that one, just a day, we should be fine. Okay, all right. So I will shelve that because we are doing, okay, core maths, statistics. So for core maths, okay, you could be asked to use only the graph to find, okay, or a histogram to find your median. Okay, but not the formula. Okay, when you are given a group frequency distribution table. But you could be asked to find the mode using the formula in core maths. Take notes. That's why we've done that. Okay, so at this point, okay, I think we have to move on to our next and critical measure. I'd wanted to start with this particular measure. Okay, oops. Okay, but I said, okay, let me start from the usual one. Okay, so we'll finish. When we finish with this, then I think we are more than ensured that will be within my target. Okay, so we are going to look at our usual median. Okay, our friend what's median. So again, you'll be asked to find the median from a raw data and that of what? A frequency distribution table, be it grouped or ungrouped. Okay, and from a raw data, you know, okay, mean, which is usually given by S bar, or sometimes mu. Okay, we can use mu also to denote what do you call it, mean, but usually we use the S bar. And it will be the sum of all your observations over the number of what observations. So if my observations are in X, S sub 1, S sub 2, up to S sub n, there should be a comma here. It's mathematically not right. Okay, then if I want to find my mean, which is S bar, it will be the sum of all the S subs. Okay, and there should be a plus here too. Okay, then divided by the number of observation, which will be n. So usually you can see that we throw this formula at you. We'll say that X bar, which is the mean, is equal to summation of X all over n. You remember? So this is a formula that we are so much familiar, okay, with. Okay, so we've started from that of the raw. Okay, so let's look at how to find the mean of the following set of what? Of numbers. So you are going to do the first one, maybe the second one together, then I'll ask you to do the rest. Okay, so quickly, let's look at A, solution. A, okay, we need and extract our observation anyway, but let's quote because in doing our calculation, we will extract it. So I won't write giving my observations. I will just go and write mean. Okay, comma, there's no I there. So S bar is equal to you know, sigma x over what, n. So that would be equal to, let's go and sum all our s values. So 2 plus 3 plus what, 4 plus 9 plus, okay, 15 plus 10, all over the number of observation, your n, 1, 2, 3, 4, 5, 6, all over 6. Okay, so you know what to do. Sum the numerator. I'm waiting for your results. Hurry up, don't let us waste time on this. You can even do this one mentally.
It's 21.5. Hey,
Mr. Haf,
43.
It's what, 43.
43,
As for the
yeah.
sum, it shouldn't be. Yes, please.
please, N is 7.
N is 7 rather. I didn't count
Yes.
well. 1, 2, 3, 4, 5. So I left one.
Yes, please.
I left which one? 2, 3, 4. Okay, I left 6. Okay, please, when you leave, you don't go and cancel. Addition is commutative. Okay, maybe it's for a good reason that I forgot. So you add at the tail end, or you add on. Don't cancel, and the position is not that important. Okay, so you are going to get 7. Okay, so then if you sum, you said you had 43 or 42?
Yes, please. 42.
43. Okay, so what then would this give us?
49.
Okay, so you had what, 49? Or this over 7?
No,
And it's
49 over 7.
49 rather, and I had 43.
Yes.
Okay, so that will give us what, 7. Okay, there is no unit here. We are dealing with numbers. So you end there. Okay, I guess, okay, Kobe was drawing my attention to the fact that the denominator, okay. Okay, I think he gave me the final result. So that would be your mean for the raw data. Is my point well made? Okay, wonderful. So with that, you should be able to do the rest. Okay, so let me skip this and move on to the frequency distribution tables. Okay, so let's look at that one. Okay, too. So frequency distribution table. And going forward, I will advise if you are given a raw data, and if you can take it to the ungroup, its corresponding ungroup frequency distribution table, do so. Okay, remember, we said when we're dealing with what the position one, we said anytime you see n in terms of frequency will be what? Changes to, in the raw formula and you are moving, the n changes to what? When you had the n plus 1 over 2, okay, when you were dealing with the raw data, we said if you are dealing with frequency distribution table, n becomes, hey, my professors here.
Sigma F.
Sigma F, very good. Okay, so take note, your mean, okay, will be equal to, you said it will be sigma x over n. Now you know your n is sigma f, so I'm replacing the n with sigma f. Is my point well made?
Yes,
It's
please.
left with my numerator, another vital information. Okay, then when you get this information, you can deal with what? Very good. You can deal with all that you are looking for, okay, in terms of the formulas. Anytime in any formula, okay, you see sigma x, which is in the raw form, the raw data. If you are moving from the raw data to either the grouped or ungrouped frequency distribution table, immediately after your sigma, okay, f should come, your frequency should come. So any formula, so assuming maybe my formula for the raw gave me maybe sigma s squared. If I'm moving from the raw to the frequency distribution table, after my sigma, I put f there. So it means here it will be sigma x. So that will give me sigma, then I bring fx. So know the raw formula. The raw one is sigma x over n. If you are moving to the frequency distribution table, your n becomes sigma f. Then after your sigma f comes, then your quantity will still be there. Is my point well made, or I should come again? So my point is, anytime you are moving, okay, from the raw to the frequency distribution table, whenever you see N, it becomes, okay, sigma F. Okay, and again, wherever you see, take note, sigma X, okay, you after your sigma, you attach what? F. So it will be sigma Fs. So introduce sigma after. So let me write, introduce, not sigma rather, but F. Okay, F immediately after your sigma. Immediately after your sigma, okay, sign, as simple as that. So if you know this information, okay, then anytime you know the formula for the raw, you should be able to quote that of the frequency distribution table without any struggle. And going forward, that is what we'll be doing. Okay, now here, this is what we are going to do. Okay, with this particular question, if you want to look at the solution as usual, this is how best you look at the solution. You write solution first. Okay, whenever a frequency distribution table is given, that table will always give you that category and the frequency, and that must always be extracted. After that, you come and quote the formula. Okay, and when you are quoting the formula, I advise that you leave a line from your table to where you quote the formula. You leave at least a line or maximum 2 lines, because you will be writing below in terms of the sum. So if you come and write the formula here directly after your table, okay, you know you wouldn't get a space to write, okay, your sums, your sigmas. Okay, take notes. This is just by experience, you should know this. So at this point, I will quote the formula, and the formula will tell me what to do. The formula is telling me that I will need sigma F. So meaning I need to get a column for what? For, okay, F. Okay, and F usually will be your frequency. So after writing your frequency, you go and put in brackets F. They're very important. Okay, after getting your F, I will need the product of F and X. And if your data comes in the ungrouped frequency distribution table, your column, first column, which will be your category, will always be your X. So it means this will be your X. So you now know, you know your F, you know your X will be your observations here. So I can find, before I can find the sum, this is sigma Fs. So I have to find the product of F and X before I can sum. And please take notes. Okay, don't write this way, F, okay, in brackets X. It can mean another thing. I hope you agree with me, especially the native math student. Even core math student do functions. So you can see that this could mean a function of X. You get my point? So when you are writing it, write it this way. Don't put any of them in brackets. Take notes. Okay, so at this point, okay, if before you can find the summation of Fx, you need to fill this column for the product of F and X. So it will be 7 times 2. You do that, and that will give you the values that you have here. By then, we had done the sum of what's this, because we could easily do that. Okay, now you come and get the sum here, which will give us 150. So the mean will be equal to 150 over 10, which will give us what? 15. Okay, and here it came with, what do you call it? Units, so you don't forget to attach your units. But remember, I've told you, anytime you move from one line to the next line, you write close to the margin, so you have to move this one to the side. Okay. During their time, they were not using constraint. Okay, so they could write it this way. They could request for any number of supplementary sheet that they wanted. Is my point well made? Hello, is my point well made? Okay, so if that's the case, then we can move on to, okay, the next one. So this one too, you should be able to relate. Okay, you quote the formula will guide you, will tell you that you need, okay, don't forget your X. Okay, oh, this one is for the group, forgive me. So let me introduce you to the, and I've told you, once you know the formula for the frequency distribution table, it is the same. That's why I use frequency distribution table. So whether it is for grouped or ungrouped, it's the same formula. So with this one, we quote, okay, the mean, which will be X bar, will also be equal to sigma Fx over sigma F. However, the only, okay, information here that I need to add is that, okay, unlike the ungrouped, where your F is known directly and your X equally known, because your first category will be X and your frequency will be your F. Okay, here, no, you cannot call this X because these are not values, they are classes. So we have to get a representation for the classes in terms of X, and that will call for the class midpoint. Remember, I said it's a class midpoint that we represent by X, and we know how to find the class midpoint. Okay, we said we can use the limits or we can use the boundaries. Okay, so here it was the limits that were used in finding the class midpoint. So that will be the sum of these two values divided by 2. So if you sum, you are going to get what? 14 here over 2, which will give us 7. This will give us 24 over 2, which will give us 12. And that's exactly what we did here. So with this one, you don't know the X. You are supposed to go and create a column for your X. And once X is known, you can find the product of F and X and therefore find the sum. Is my point well made? Hello, my professors, are you there?
Yes, please.
Okay, so my point is well made. Great. Okay, so on that note, okay, we know how to find the mean from raw, ungrouped, grouped frequency distribution table. So this then becomes, if you continue, therefore, you are going to get this to be equal to sigma Fx give us 1, 2, 4, 1, all over sigma F, which is what? 58. Okay, so let me see whether Eddie or Kobe will give me the answer. Okay, so I'm looking for the results. We know we are supposed to attach what the units because there is a unit given. 1241 divided by 58. Okay, so I guess my answer, okay, very good. I can see that, okay, Kobe, you are really learning. So you stated your answer in 4DP. That's what I wanted to see, whether at least you picked that information. So 396, okay, 6. Okay, but that will be, okay, in 4DP. So yes, before you indicate, always bring your unit before the approximation. So don't forget your approximation. Because in actual fact, this is equal to this and some other stories that you decided not to be interested in. So you truncated it at this point. Equal to is a very sensitive. So anytime you approximate, don't forget to, okay, otherwise you have to change this one to the approximate sign. Okay, this is not equal to this. So in this case, age, usually it is better to leave approximate in 1DP. So I'll write 21 point what? Okay, 4. Okay, yes. Do you see anything wrong with my final answer?
Yes, please.
What is wrong?
You shouldn't bring the decimal place.
Okay, so please take note. There is nothing wrong. If I use this, I have indicated that it's approximated. Okay, this and you putting it in bracket, they shouldn't move together. If I use equal to, then I have to show that it is equal to this when it is 1DP. That's when I indicate my approximation in brackets. Am I clear?
Yeah.
So you cannot use the symbol and indicate. Okay, you use, okay, one of them. Take notes. So that was just by the way. Okay, so that will be it for what we have here. Okay, in our next meeting, we'll look at the technical, okay, one. Do you have some few minutes to spare, right? Okay, the assumed mean is a little technical. So in our next meeting, we'll look at how to find, okay, the mean using the assumed mean. Okay, now questions are moving towards that. And after that, we'll look at the measures of what? Of dispersions. Okay, now this is going to be your assignment. Okay, let me see. Okay, so this is your assignment. Okay, and your assignment is going to be this. Okay, look, I shouldn't give you, my advice is even if you are giving the raw data, okay, please, if you can convert the raw data to the ungrouped frequency distribution table, do so. Okay, and I've taught you how to move from the the raw data to its corresponding ungrouped frequency distribution table. So use the table in, okay, doing this for me, though the information is in the raw form. Okay, change it to the table. So you look at your least observation, which I think will be 11. Okay, so it will be max. Your first column will be mass column. You don't know the, what do you call it? The units. Then your second column will be your frequency column. So you extract the information in the frequency distribution form. Then you go and do your tally to get your frequencies. And here our advice, don't let your second column be your frequency column. It doesn't really matter though. You can let it be your second column. And later, you know, for you to play it safe, you need another column, which is tally column. So you need a tally to do your frequency. So when you cancel, then you know how to get the tally. That's the difference. Okay, so when you get there, then I think that will be fine. We haven't done the last one. Okay, so you do up to what? Up to C for me. That is your, okay, what do you call it? Your assignment.
Mr. Akman, you said we should make a grouped frequency table.
No, not grouped, ungrouped. If I want you to use grouped, I have to give you the classes. Other than that, you all group differently.
Okay.
So change anytime you have, okay, a raw data and realize that you are dealing with a whole set of numbers. I'll usually advise if you have more than 10 observations, okay, change it to, okay, use a frequency distribution table, but it's better you use an ungrouped frequency distribution table.
Okay.
You get the point?
Perfect.
Okay, so you should be able to convert this one to its corresponding ungrouped frequency distribution table. Then after that, you quote the formulas using the frequency, okay, distribution table. So you do I up towards C. Okay, we couldn't do D. God willing, tomorrow we'll continue with the D, okay, and the rest that we have here. Then in our next meeting, we'll look at the graphs. Okay, I have 3 days for statistics and we are, okay, I think on course. Okay, all right. Okay, so any questions at this point before I finally bring the curtains down? I wish we had finished with the assumed mean so that next time we'll do only the measures of dispersion, but no issues. Assuming was my target. That's why I separated this one. I wanted us to finish with all the measures of the central tendencies for now, the main ones. Any questions? Are we all fine?
Yes, please.
Okay, great. So if that's the case, then we are going to end here. Okay, and you submit your assignment. It's Core Math, so make sure you submit it to your Core Math platform that you've created. If you send it to the Relative Math, you'll be doing Core Math exercise in your Relative Math exercise book, which shouldn't be. Okay, so we'll find a time and do that. So let's talk, okay, backdoor. Okay, Prof. Kobe, is that clear? Okay, all right. So on this note, thank you very much. Okay, God bless us all. Tomorrow, don't forget, we'll continue with what? The Core Math vectors. Okay, so bye-bye.